Well, this is the biggest computing revolution we have ever seen. No one has ever seen a technology like this. A computer that writes software itself, and now the computer can write software for other computers by itself. When you take a step back and think about the implications, it's really, really profound. And all of our experiences, every single one of ours, I'm sure, has proven that. This is the easiest application to use in the history of computing because it's so smart. It understands what you mean, even when you say what you mean poorly. And it does things that you tell it to do that exceed your expectations. And you can connect it to almost anything. It's a universal translator. And so when you take a step back and think about its implications, I think we can all be fairly excited about all of us in the computer industry, what we've done. I woke up this morning without a voice. I have no idea where it went. I'm going to find it here somewhere. And so, but the big deal here, Sarah, is that we're going to bring the world's best compute engine to the world's most valuable data. You know, back in the old days when we first started our career, and Frank mentioned how long he's been working. I've been doing my job a long time. I'm not that old. You're old. And
they think that's funny.
Well, they know it's true. And so back in the old days, we used to bring data to the computer. And the reason for that is because there's so little data to move. But these days, for all the reasons that we know well, the data is gigantic, the data is valuable, it has to be secure, it's regulated, governance has to be incredible. And so it's tough to move data around. The data gravity is real. And so it's a lot easier for us to bring our compute engine to Snowflake. And our partnership is about accelerating Snowflake, but it's also about bringing AI to Snowflake. You know that at the core, the big revolution is about the combination of data plus AI algorithms plus compute engine. Our combination, our collaboration here, our partnership, brings all of those three things together. Incredibly valuable data, incredibly great AI, incredibly great compute engine. And the thing that we can do together is to help customers use their proprietary data and write AI applications with it. You know, the big breakthrough here, and this is, I'm sure you guys are going to learn a lot about this during this week, is that for the very first time, you could develop a large language model, you stick it in front of your data, and you talk to your data. You talk to your data like you talk to a person. And that data will be augmented would augment the large language model, and you'll ask it all kinds of questions about what and how and when and why. All of the things that you might query the database in the future, you'll talk to the database in the future. The combination of a large language model plus knowledge base equals an AI application. It's as simple as that. A large language model turns any data knowledge base into an application. And just think about all of the amazing applications that people have written. It's always at the core of it some valuable data. Now you have a query engine, universal query engine in front of it that's super intelligent, and you can get it to, of course, respond to you, but you can also connect it to an agent, as you know. And this is the breakthrough of LangChain plus vector databases plus data from large language models. Groundbreaking stuff is happening everywhere. Now everybody's going to do it. And Frank and I are going to help everybody do that. You know, Frank, it's like this. There are tons of customers in the audience who have large customer support organizations.
Yeah.
And all that data is going into Snowflake. Could you imagine if you had hundreds of your customer support agents sitting in front of you and you just asked them a whole bunch of questions? That's the future. Yeah. You're going to put a large language model in front of that customer service database, and you're going to talk to it.
Yep.
You're going to ask, what are the most frequent things that are happening to our customers that we could improve on? What are the things that they seem to find really delightful about our products? You could ask those questions in normal human language, and it will talk back to you. That's the miracle. You're going to turn customer service data into a customer service application. First of all, I have never met an employee that was too smart. You know, it embarrassed me how smart they were. I've never hired a new college grad. I just went, too smart, too smart.
There's a lot of NVIDIA teammates out here, guys.
So we can make the pre-trained models as smart as we can. And then we still have to onboard them. We still have to fine-tune them. We still have to, we have to still specialize them into our particular craft. And so our strategy and our offering is state-of-the-art pre-trained models of a variety of sizes. And sometimes you need to create a very large pre-trained model so that it can generate prompts so that you could teach the smaller models, which generates prompts to teach even smaller models. And the smaller models could run almost anything, and maybe the latency is really, really low. However, it doesn't generalize as well. It's, zero-shot capability is probably a lot more limited. And so you might have several different types of different sizes of models. But in every single case, you have to do supervised fine-tuning, you have to do reinforcement learning, human feedback, so that you could keep it aligned to your goals and principles. And you need to guardrail it, and you need to augment it with vector databases and things like that. And so all of that comes together in a platform. And we have the skills and the knowledge and the basic platform to help them create their own AI. And then connect it to the incredible data that Frank has in Snowflake. Now, ultimately, what every enterprise customer will do is not ultimate. Their goal shouldn't be to think about how do I build a large language model. Their goal should be how do I build an AI application that solves this particular problem. And that application might require 17 questions and previous prompts that it finally came to the right answer. And then you might say, now I would like to take these, I would like you to write me a program, and it could be a SQL program, it could be a Python program, so that I could do this automatically in the future. And so you still have to guide this AI through, as you know, so that it could ultimately give you the right answer, but then after that you can create an application that could run as an agent 24/7, looking for circumstances like this and revealing it to you in advance. And so our job is to help customers build these AI applications that are guardrailed and specific and customized to them. And then lastly, we're all going to be intelligence manufacturers. In the future, we'll hire employees, of course, but we're going to create a whole bunch of agents, and these agents could be created with LangChain or something like that connects models and knowledge bases and other APIs, and you deploy in the cloud and connect it to all the Snowflake data.
We have 5 AI factories at NVIDIA, and 4 of them are in the world's top 500 supercomputers, and another one is coming online as we speak. We use those supercomputers to do pre-trained models. And so when you use our NeMo AI Foundation service inside Snowflake, the first thing you're going to get is a state-of-the-art pre-trained model that tens of millions of dollars of expense has already gone into it, not to mention all the R&D that went into it. And so it's pre-trained. And it's like a new college grad pre-trained, super smart. And
not so smart that you're scared.
Not so smart, well, not so smart as me, but I'm just smart, super smart. And so they're pre-trained. And then there's a whole bunch of other models around it, and those models for fine-tuning, for human feedback, reinforcement learning, human feedback, for augmentation, all of those models are a lot more cost-effective to train. And so now you've adapted that pre-trained model to your functionality, to your guardrails, to be able to optimize for the type of skills or functionality you would like it to have, and augment it with your data. And so that is going to be a lot more cost-effective. And the important thing is here, what I hope, and I believe this will happen, is that you'll be able to develop AI applications connected to your data at Snowflake in a matter of days, not months. you should be able to build AI applications quickly in the future. And the reason for that is because we're seeing it happening in real time right now as we speak. Isn't that right? Communities are, almost enthusiasts and developers are creating all kinds of applications with LangChain and Pinecone and whatever data that they have. Chat PDF is pretty terrific. You load a bunch of PDFs into it, you talk to your PDF. And instead of reading a research paper, this morning I was asking this chat PDF about this particular piece of research, which is a lot more interesting having a conversation about it than having to read the whole thing. And it happens to be like 49 pages. And so being able to ask a few questions about it is really a lot more productive. Yeah. You're going to be able to do this almost everywhere. That we're living through right now the first fundamental computing platform change in 60 years. If you just read the press release of the IBM System 360, you will hear about central processing units, I/O subsystems, DMA controllers, virtual memory, multitasking, scalable computing, forward and backwards compatibility. You're going to hear about all those things literally written in 1964. And those words have carried us with CPU scaling, right, for 60 years. But that has run its course. We can't scale CPUs anymore. And that is now well understood. At exactly the same time that all of a sudden software is different. The way that software is written, the way that software is operated, and what software can do is profoundly different than it was before. Isn't that right? You call it software 2.0, and now we're talking about software 3.0. The fact of the matter is, computing has fundamentally changed. And so we're seeing two fundamental dynamics happening at the same time. That's the reason why things are shaken up so hard. On the one hand, you can't just keep on buying CPUs. You know that. And the reason for that is because if you bought a whole bunch more CPUs next year, your computing throughput would be no more than if you didn't touch it at all, because it's the end of CPU scaling. You would spend a whole bunch more money, you wouldn't get a lot more throughput. And so the answer is you have to go accelerate it. The Turing Award winners spoke about acceleration. NVIDIA has pioneered acceleration. And so accelerated computing is now here. The second part of it, of course, is the whole operating system on top of that computer is profoundly different. We have a layer called NVIDIA AI Enterprise. NVIDIA AI Enterprise, data processing, training, inference, deployment, that entire end-to-end is now integrated into, or in the path of being integrated into Snowflake, so that the compute engine underneath, from the beginning of data processing all the way to the large language models, are now going to be completely accelerated. We're going to turbocharge the living daylights out of Snowflake. That's our mission. And you'll be able to do more, and you'll be able to do more with less. And so it's very, very evident. If you go to any of the clouds, you will see that NVIDIA GPUs are the most expensive compute instances. But if you put a workload on it, you will find that we do it so fast, it's as if you got a 90% discount. You said 90% earlier, it's in fact 10 to 1. And so what's interesting is that we're the most expensive instance, but we're the most cost-effective TCO. So if your job is to run workloads, then the best way to do it is acceleration. An example workload is training large language models. An example workload is fine-tuning large language models. If you want to do that, absolutely do not accelerate it. Please do accelerate it. So accelerate every workload you can, and that's the reinvention of the whole stack. The processor is different, the operating system is different, the large language model is different, and now the way you write AI applications is different. Isn't that right? Software 3.0. You don't have to write it at all. AI applications. We're all going to write applications. We're all going to connect our prompts and our context and our few Python commands, right? We're going to connect it to a large language model. We're going to connect it to our own database or the corporate database, and we'll develop our own application. Everybody's going to be an application developer.
I would ask myself, number one, what is my single most valuable database? And the second thing I would ask myself is, if I had a super smart person in front of it, and everything goes through that super intelligence, what would I...
smart person.
Scary smart person. What would I ask that person? And it is...
Can I guess? Is it the customer database?
Customer database, in the case, because Frank has a lot of customers, I don't have that many customers.
Or the asset database if you're manufacturing supply chain.
Yeah, so my supply chain is super complicated. Mm-hmm. And my design database is super complicated. It's impossible for NVIDIA to build our GPUs without AI anymore, because none of our engineers can go through the number of iterations and exploration that AIs could do for us. And so when we were coming up with AI, our first application was ourselves. And so, Hopper couldn't have been designed without AI, and our next generation cannot be designed without AI. None of our optimizing compilers could be done without AI. Just optimizing the graph is so complicated because there's so many targets, so many GPUs, so many different neural network models, so many different constraints that you're optimizing for. No human could possibly compile for that, optimize for that. And so we have AIs just run continuously looking for the best optimal solutions. Yeah. And so we apply our AIs to our own data. We would do that, of course. Our bugs database is a perfect place because we have so much code. We've got to go and figure out where, how to as quickly as possible enable our engineers. We have, we're a full stack company. If you look at the amount of code that goes through NVIDIA AI, it's several hundred packages of software that comes together so that an application can sit up here, be accelerated by a factor of 50 on top of a GPU, and then scale across a full data center. That piece of software called NVIDIA AI Enterprise is insanely complicated. We need in the future, and these are some of the things that we're working on now, is how do we use an AI to go figure out how to security patch it, how to best maintain it, so that we can keep compatibility, so that we don't have to disturb the entire upper layer in the meantime, support backwards compatibility, maybe support a particular security hole, et cetera, et cetera.
And these are questions that AI is capable of answering for you
That's
today.
That's right, exactly. We can use a large language model to go answer those questions.
Yeah.
And then find the answer for us or reveal the exposure to us, and then the engineer will be able to go in and fix it.
Yeah.
Yeah. Or recommend a fix, and then we can be the human in the loop to go acknowledge whether this is a good fix or there's a better fix.